Okay, we have a full agenda. We are going to start on time. I'm Mike Jones. My co-chair is Ivo, and we will be having a lot of good COSE discussions today. So note well to note well, as I've heard Leif and others say. It's a condition of participation. Meeting tips. Do sign in to the Meet Echo Lite without audio. You will use it to queue when you want to speak. That is true both of in-person participants and remote participants, so that we can be fair about letting people participate. Wear masks unless you're speaking at a microphone. And if you're remote, make sure your microphone is off unless you're actively presenting. Thank you. This is a standard set of resources, which has been in all the chair slides, including the agenda from which you can join. We do have one volunteer for note-taking. I would like to get a second person who's willing to tag team and help. Okay, I'm going to start volunteering people if I don't get a volunteer. Tell you what, Hannes, when you're not presenting, can you tag team on the note taking? Thank you very much. And maybe Russ, could you do it when Hannes is presenting? Thank you. We have quite a full agenda. I'm going to be ruthless with the clock. Should I need to, I would ask the presenters to try to stay within their time slots. We have a lot of interesting material and discussions to be had. The good news is that we've finished a bunch of RFCs, and there's 2 more about to be finished. Thanks to Paul for encouraging us, and for those who did the work for getting us there. It's been a journey, but we now have an internet standard for COSE. And with that, I am going to switch to Russ.
Thank you. Next slide, please. So the topic is whether we should support a couple of non-authenticated encryption algorithms. We proposed this at the last IETF, put together a draft. The SUIT working group for their firmware encryption draft is using it. And just last month, this working group adopted the draft to assign 2 code points. Next slide. Basically, code points for counter mode with 3 key sizes and CBC mode with 3 key sizes, all marked as deprecated in the IANA registry, just to make sure that people don't accidentally use them when they think they are getting an authenticated mode. The document tells them it has to be used with some mechanism, such as a digital signature, in order to provide that integrity. Next slide, please. Last week or the week before, we got a bunch of comments about the things that can go wrong when you don't have authentication. We knew these, of course, but we did address these specific things in proposed security consideration text. Next slide. So there's basically three possible ways forward. One is we adopt that security considerations text and assign those code points. It was observed in the concerns that the padding attack does have some concerns above and beyond counter mode, the padding associated with CBC. So one thing we could do, since the bootloader implementation seemed to prefer counter mode anyway, is we could drop CBC and proceed with just one of the modes. Or the third thing is we can tell the suit working group, no, if it's not authenticated encryption, we're not going to register it. And then what that means is at least those bootloaders who are insisting on using counter mode will not implement the standard. So those are our three choices and the consequences thereof. And I'd like to know what the working group wants to do. That's the question.
I'm not making any comments. I'm just relaying a couple things from the list in case people haven't seen it.
Please introduce yourself when
I'm
speaking.
Brendan. I was in the queue, so I thought I had introduced myself virtually.
It still helps. It helps the note taker.
Fair enough. Yes. The first was there's been some commentary that maybe we can say something that's more severe than deprecated, like special considerations or something like that. I'm not sure, but maybe that's an option. The other comment was that there are some AEADs that maybe do work out of order if you squint at them just enough. I don't know. I'm not a cryptographer.
Mike Prorock.
Thank you. Michael Prorock here. I believe for sure option one should be done. Let's add, even though the security considerations is getting long here.
It's longer than the rest of the
I
document.
know. It's there are similar things in some of the other things that I'm working on, right, with very long hashes. So, but I do think there's a high degree of value in registering, even if it's marked deprecated or do not use or some other stronger language. If for no other reason is that then that will encourage someone who thinks, oh, I found this neat thing. Let me go look up what's going on with this. And then they see mountains of security considerations and realize why this might be a bad thing, unless they really, really know what they're doing and have a very specific use case. So that is not to say that there aren't highly specific use cases for this. Personal feelings are, and having talked a bit with some of the suit folks and things like that, is that there might be a better way out. At the very least, if we register this, this might provide a stopgap mechanism just to continue proofing things out, as long as we're very clear we're not trying to advocate for the use of this broadly. Right.
Richard Barnes.
Yeah, hey, just kind of riffing on Brendan's suggestion about something stronger than deprecated. I wonder if it would be possible to do something like mark these as reserved, these code points as reserved, allocate some code points to the IANA registry, but mark them as reserved. And then in some suit documents, define their usage in a special suit way. It's a bit of a hack, but like that it provides a pretty strong. It means like no one's going to come across the registry, be scanning for things and say, oh, there's a CBC thing here, I can use this, and then never even get to the security. I'm a bit entertained by Michael's assumption people are going to pull up the document and see if the security thing is considered. Right, but having reserve would prevent that sort of risk.
So Richard, I would not want it to be hard to find out what algorithm that code point meant, which seems to be what you're proposing.
You could do something, I think, maybe like list the suit document that defines the acknowledged should be mostly safe usage as a reference in the registry for why it's reserved.
Sure. We could say only for use with X.
Precisely. So you basically define a special use code that was only meaningful in the scope of that specific usage. Which, if someone comes up with a second usage for CTR or CBC, like, could get awkward. But hopefully, one might hope that those won't come up too often.
Okay, Gern?
Göran Selander. I'm not sure I understood Richard's proposal there, but there are legitimate uses of, there are multiple legitimate uses of counter mode, for example. So we have in the Sigma protocol, the second message only needs indistinguishability against chosen plaintext attack. So ASCTR would be a good fit there. So I support options 1 or 2 here, and I don't think there should be a sort of restriction on how you use them, because, unless it's a very easy way to update that, and that might be a very long list of things where you want to make this special cases.
Okay, Chair, how do we decide?
So far, I hear people speaking for option 1 and 2.
I heard 1 and 2, but not 3, which is I'm encouraged by.
Not 3. And not wearing my chair hat, I would encourage us to follow normal registration processes, unless there's a strong reason not to. I did hear Jörn come to the mic say there may be multiple uses for these, which I think argues against making them special purpose. Okay. With that, thank you for your time. We can continue this on the list. Hannes, okay. It's your turn.
Thank you.
Thank you, Mike. Okay, HP key. Next slide. It looked like a very easy document at the beginning. And we had a discussion at the last IETF meeting, which also was uncontroversial, about the encoding of the encrypt or the output of the HP key. Then following the confirmation call on the mailing list, it turned out that that was not quite true. And the alternatives were proposed, but those couldn't we couldn't reach a conclusion either, which is why the chairs, specifically Mike, posted a mail to the list mentioning that outcome of that call. So I put a few slides in here for you to look at what the current proposals are, in addition to what's in the working group document, which I hadn't updated because obviously we need to first have a conclusion on what we updated with. Next slide. So Daisuke made a very specific proposal, and I color coded the important information here. So there is, so this is the, this is sort of like encrypt 0 payload, where the use of HBKE is, oops, one back. Oh. What? Okay, is indicated using this HBKE algorithm, which we would have to register. And then the essence or the core of the information that is being passed around is in this newly introduced HBKE sender information structure, which contains, which is a map containing of a few fields, namely the KEM, the KDF, and the AAD, which is populated with values from the HBKE established registries. The ENC field is the output of the HBKE algorithm, and it's obviously abbreviated here. So that's his proposal. The next slide. Hilary's proposal layers on top of this, and instead of, he makes a few changes. Maybe actually we go to the next slide. This is sort of the textual description of what you see here is to use an array instead of a map, thereby and making it non-extensible, and omitting the KEM. And he believes that one can come up with processing rules for sort of guessing what the chem then is. Otherwise, it's conceptually similar, I would say, except for those changes. Although he did raise a few new points on the mailing list, new issues that we may or may not introduce, which I were kind of completely new, weren't raised previously, so I omitted them here. But in essence, those are the two proposals, and that there are actually three proposals. There's the original one. Neither Richard nor Hilary or none of the vocal proponents like that idea, but this is kind of what these two proposals are what we zeroed in. And if you have any preference on what you would like to do, that would be highly welcome. That's what I'm essentially saying with the last slide. So it's like, besides a small number of people who have strong opinions, we haven't come up with something yet.
Yeah,
Jon Selander. So I apologize, I haven't really looked at all the details here, but your proposal is a COSE key. That's what remains in the draft. And these are the two counter proposals against that. And basically they are indexed by the chem algorithm, which then creates this new entire format. So you basically read off from the chem the -1 that this is a chem, and then sorry, this is an HP key, and then all the rest of the fields are defined by that. Is that understanding the proposal?
Yeah, like that's correct. In some sense, we are really talking about how to encode the different fields that are communicated, and there are not that many fields, right? There's the chem, the AADID, the KDF, and of course the encryption field, and that needs to go somewhere. And the question is, where should that go? It like on a very high level, it doesn't sound like rocket science.
Lawrence?
Yeah, Lawrence Dunblade. So in all the proposals, the algorithm, top level algorithm, is just HPKE. And this seems like a divergence from what everything else is in COSE, where you kind of have the top level algorithm is more of a cipher suite that specifies all the things. Now I know the fan out here can be quite large, but one of the advantages I thought of the cipher suite at the top level, or two advantages I see of the cipher suite at the top level, is you just have to look at that algorithm ID to know whether you can support it or not. You don't have to decode a lot deeper into it. And it allows us to register only sensible cipher suites and avoid some of the fan out. So my gut reaction is I would prefer that and not to diverge what COSE has done in the past. And I think there's some good reasons for that.
Yeah, that mirrors what is currently described in the working group document, but that approach didn't find a lot of sympathy because the vision was that the HPKE guys would register new algorithms and then they would become instantly available in COSE HPKE by reusing the existing registry. That's why the way how these three fields are structured, it's kind of populated with the values from the existing registry. Whether that's a gigantic benefit or not, that's in the eye of the beholder, but yeah, that's at least, that's the rationale. Mike?
Yeah, Michael Prorock.
Yeah, I'm going to echo similar support for the way the document's written now. Not seeing a huge benefit to diverging massively from the existing methods that are being taken with the COSE registry. It seems to make sense for the same reason, like point at the alg, go after this, right? Follow a common sense approach there. I have a little bit of concern pointing out to a secondary registry and then just we magically get something, right? Well, maybe that's good, maybe that's bad. And I'm a little more concerned about that approach, especially because HPKE is such a special case, right? It's not really going down the same path as what we normally deal with saying, oh, I've got this very well-defined family of algorithms, this, exact specific algorithm and parameter set. It's more facilitating use of that in other contexts, right? So.
Richard, and then we'll move on.
So just one quick clarification on what Mike said. I'm ambivalent on the question of how we indicate algorithms. For what it's worth, MLS, another HPKE user, did choose to define specific code points that are combinations of HPKE sub-algorithms. So it wouldn't be totally unprecedented to do that here. But you would have the lack of agility, as was pointed out. I do think that it is not an option to go with the document exactly as it is right now, because we need to update to fix this code key problem and represent the encapsulated value as opaque bytes. So some change is necessary here.
Thank you. Any closing remarks, Hannes?
Yeah, I think just keep discussing it and hopefully finding a solution at the end of the day.
All right, next we'll have the CBOR encoded cert, yes?
Excellent. So, hi all. Yes, it's Joel Höglund speaking, and we wanted to give you an update on the status and ongoing work on the CBOR encoded X509 certificates, and also to remind everybody to come with input on those issues where, yeah, input is valuable. Next slide, please. Oh, that's what I already covered. One more, please. And as a quick reminder of the overall trade-offs, so this is all about finding the good trade-offs between compactness and convenience to parse and process for IoT devices, while still being general enough to encode as many relevant X509 certificates as possible. So these are the different goals that we try to balance in this proposal. And now I'm going to relatively quickly step through a number of open issues, and then depending on time and interest, maybe actually gather some input. But most of it will be for your information, and then if there is interest, we're definitely interested in hearing input on basically all of this, even though we have our own proposals for solving most of them. So a recurring topic is whether the minor optimizations that was proposed in the beginning should be kept, because they make the processing a bit more complex, but they are needed to actually reach the very most compact cases for IoT profiling. So we are basically inclined to keep them unless there is a big outcry for making it simpler and more streamlined. Next, please. So this is about the encoding of signature algorithms. And as some of you might know, there is still SHA-1 being used out in the wild, meaning to actually be a general purpose format, we need to handle these types of signature encodings. And there has been some discussion of whether they should be punished in terms of being having longer encodings, but we think that as long as they are used for many CA certificates, it doesn't really make sense to actively punish them, that rather we should keep it in the same range as other signature algorithms. So we propose to use normal 2-byte assignments to cover these signature algorithms. Next, please. So this is also more on the info stage, that there has been already it's been observed that what we're proposing here should also benefit in terms of revocation lists and OCSP messaging. And Rice and Ericsson together have been having a master thesis which has been looking into this. So this is something we hope to be feeding back into the existing proposals. Next, please. And this is also just to make sure that it is self-contained, the draft in terms of actual usability for IoT, because right now we list a big number of algorithms, and not all of them are, of course, suitable for IoT. So this is just a sanity check to make sure that we keep the knowledge on what are actually good algorithms for the IoT cases that we try to promote. Next, please. So this is a bullet where input from a larger audience would be valuable, even though from our perspective, there has been discussions on whether we should propose more complex structure where broadly, well, back up one step. So basically that there could be certificate chain optimizations done if we would allow two-pass parsing of certificate chains. But from our perspective, we see that this would add too much complexity to the parsing engine and make it less suitable for the IoT device, the scenarios that at least I care deeply about, and that rather it could be handled through additional COSE headers and external broadly compression. But this is somewhere if the audience has strong opinions, we are very interested in hearing them. But now we step on and take eventual discussions at the end. Next, please. So this is a short break to applaud many insightful observations from Ilari, and we are addressing them, and I will speak about some of them. Next, please. So this is basically work in progress to handle kind of more corner cases that we had missed in the initial proposal. So these are all kind of fixes to make it more general for the next version of the draft. Next, please. And this is again an important highlighting that currently the IP range encoding could theoretically break the CBOR int encoding if you would have, since we encode differences. So if you would have a crazy subnet where you would care to cover too much of the IP subspace, you could in theory break it. And instead of trying to address this, as we see very much corner case, we should make it clear that this is a limitation of the existing proposal. Next, please. Oh, this is yet the last issue where also input from audience could be really useful. That Ilari made a real-life observation about the authority key identifier, that in real life, actual certificates lack one of the sub-parameters. And this can be fixed by allowing null encoding to cover these cases. But that leaves two of the other sub-parameters, which we in our investigations have not found to need null encoding as well, but we haven't done extensive studies. So if this is a real life problem, we should allow also these sub-parameters to be encoded as null. And this we are open for adjusting if we think that is a problem that needs addressing. Otherwise, it's all about clarifying the assumptions that we have made. And that was the last issue that I wanted to present to you. And of course, we're very happy for comments now or on the mailing list as we are progressing with this work. Thank you.
Any questions? If so, please join the queue. All right. Thank you, Joel. At this point, we'll turn it to Tobias for the BLS key representation draft.
Next slide. So this is just a quick update and refresher on this draft. So it defines and registers the required parameters, Diana, for the cryptographic key representation for the Barreto-Lin-Scott elliptic curve family, so BLS curves, for representation in both COSE-Key and JWK. Next slide. So why do it? Well, Barreto-Lin-Scott elliptic curves have a couple of special properties to them, they are known as pairing friendly, which allows different signature style primitives. Two of such are current drafts of the CFRG. BLS signatures is one notable that has been a draft for some time. There is also a pairing friendly curves draft that was recently updated, which formally defines the curves. And then lastly, there is also another signature scheme draft that I'm also a co-author of that was newly adopted at the CFRG since the last IETF meeting. And both of these make use of the BLS curve, which is, as per industry adoption, the most popular of the pairing curve family right now. Next slide. And so just a very basic status update. As spoken about, it's a simple draft, primarily registering these parameters. The draft was adopted since IETF115. We published recently an update which added JWK-based examples, and I'm close to filing a PR and making a publication for adding the COSE-Key examples. Next slide.
That's it.
Oh, that's it.
So Tobias, do you have any questions to the working group at this point, or what actions would you like them to take?
No explicit actions beyond just helping to review the draft. The COSE-Key examples should be in fairly soon, in the next couple of days. So reviewing it with, I guess, with an eye to next steps as per the process is probably the next steps. Thanks.
Okay. Are there any questions from the floor? All right. Thank you, Tobias. Now I'm going to switch roles and be an individual participant for presenting another draft that Tobias and I had written together. This is the claims in COSE headers draft. So what does it do? It enables us to represent a set of CBOR Web Token claims in a special COSE header. They're put into a header parameter in an object, in a structure, because otherwise there would be name collisions or number collisions between the header parameter namespace and the claims namespace. So why do it? There's use cases, and this first showed up in Jose most of a decade ago, where it's useful to be able to have, for instance, an unencrypted version of a claim that you use for processing an encrypted JOT or an encrypted CBOR Web Token or COSE structure. For instance, you might want to know what the issuer is before you even try to decrypt it. Jose and JOTS had that. We did not. We adopted this draft to be able to do that. So it's a very simple draft that does one thing. It was adopted in July, thank you. We just published 01. It is a one-line change from 00 that changes the motivating example to issuer. I will say, having reread it again with fresh eyes in the last few days, I think it would be beneficial to add an example. And I know Karsten had asked about, well, should we add CDDL, as Karsten is wont to do. I don't see Karsten here. There must be a conflict, but I intend to ask Karsten about that offline. So my question, and this is where Eva is going to have to chair for a moment, is it time for working group last call? This is stable, and I don't see much happening to it beyond the current status other than possibly adding an example.
Yes, we can start the working group last call unless they are.
Eva, you are muted if you're trying to speak to us.
Wait.
Jörn?
Jörn Selander. So I'd like, I actually didn't understand the example you mentioned here with the unprotected header. Why not use unprotected header and put information in that? So I think an example would be great. That's true, and maybe that's good to have before we have working group last call.
I know there'd been something on the mailing list about unprotected headers. It's not clear to me that they're the same thing because they're a different namespace. One is claims, one is header parameters. They're distinct. Lawrence?
Yeah, I was just going to answer that question. Is that if you're decoding MIME headers or content type headers, you have access to that parameter, and then you can switch on that before you bring up the CBOR encoder or whatever. So it seems like it's definitely a benefit to implementations.
Still transmute. Now, just to ask the question sort of very concretely, this ISS promotion applies to both the protected and the unprotected header, or just the protected header?
In a COSE sign 0, there is no unprotected header. If you're using a COSE sign 1 structure, I believe that there is an unprotected header. It's a fair question whether we want this header parameter to appear unprotected ever. And that's something we could discuss if we do have working group last call, which is up to Evo to decide. You could add that as a working group last call comment.
Do you hear me now? Or is it still?
Can you speak louder, Eva?
Okay, so maybe we can see in the room if there are people that are for or against the working group last call. I think in either case we will confirm it on the mailing list if there is enough support. So in the room, maybe let's use the voting tool.
Do you know how to start that, Eva?
I think so. So those that are in favor of starting the working group last call, please raise your hand. And if there are people that are against it, please also. We'll have a separate vote for that. I'll wait a few more seconds. Okay, so I see 11 people believe we are ready for working group class code. There are some people that think it's still a little bit early. For the minutes, 12 people are for and 2 are against. If the people have, if people want to clarify why they think it's still not ready, please speak up on the mic now. Yes,
Hannes. We just raised 2 open issues and the need to add an example and to find out whether these fields also apply to the unprotected header. It sounds like it would be good to at least update the document briefly and add that example. I think that could happen quickly. Actually, there was the third issue as well with the CDDL, like having 3 open issues appears to be premature to call it working group last call, right?
Yes, okay. But with those issues resolved, I guess then we'll be able to go for working group last call. And that is my reading of the results. So yes, Mike, please take those action items on those 3 issues, and then we can go to working group last call.
Thank you. We're at time, and I see that queue is cleared. So let's move on to Mike Prorock talking about post-quantum signatures. Thank you all.
Thank you, Mr. Jones. Wait for that deck to pop up. Mike Prorock here. Kind of continuing on, this is the second update since the working group gracefully accepted this draft to help us move it forward. Next slide. Just a quick recap on post-quantum and why we're dealing with this. And it largely is because we're seeing interesting changes to that potentially threaten the way we've been handling especially public key cryptography and certain signature methods based on use of quantum entanglement and all sorts of other fun things with qubits that help us unpack keys and relationships within data sooner. We have selected to go after 3 algorithms here, and we'll come back to some implications from that from a signature scheme standpoint. But the ones we have gone after are 2 lattice-based ones as well as a hash-based approach based on feedback from NIST and where things are at as far as the candidates for standardization. Next step. So once again, as mentioned, we've gone after 3. That's Sphinx, Falcon, and dilithium. And the key thing here is to get us a leapfrog past and be able to start testing effectively for interoperability with things that do require signatures, whether that's CWTs, JWTs, verifiable credentials over in the World Wide Web Consortium side of the world and things like that. So it's really setting ourselves up for cryptographic agility and to be able to set a path for registration of future post-quantum algorithms and signature suites as required possibly by COSE and or Jose usage. And also to get these IANA registrations in. And because of the parameterization, especially with some of these algorithms that can be quite tricky, let's make sure we've very clearly defined that and how we would use those here, pointing back to CFRG and NIST. Next slide. So big downsides, large key sizes, large signatures, typically larger signing times, verification times are very nice. Next slide. Couple of key draft updates here. We've gone ahead and completed out the sections on Falcon and Sphinx Plus. We've gone through and detailed out the likely parameter sets that will see usage, though these are obviously subject to change up until these algorithms are fully standardized at NIST and elsewhere. We are using a combination because of some of the unique parameters based on the way, especially the Jose spec is originally written around KTY and ALG, so that we have the family of algorithms specified by the KTY. ALG is specifying the actual algorithm itself as well as the parameter set in use. Next slide. Next steps. This is really the big question for the working group. Gut feel at this point, especially seeing possible lags with one versus another, is should we split this into 3 drafts? Now that the bulk of the work has been done, we could pretty easily do that. And instead of having one post-quantum signature scheme draft that covers the 3 initial ones, we could split those up so that they can be actually moved forward should that occur sooner with one versus another. Or so that we can let one die if we need to for whatever reason. The proposed names at this point would be Draft IETF COSE, Dilithium, Falcon, and Sphinx Plus. We are awaiting, obviously, finalization on parameter sets. We'd love any feedback from that if anyone's heard anything that we haven't, and generalized guidance from the group, since this is kind of the first draft I started on with IETF, on anything I might be messing up on or could do better. So thanks so much. And do want to make sure there's a good shout out to Ori and all the others who have been helping us out, especially Christine and actually some of the authors of things like Sphinx and Falcon, etc.
Okay. I'm Quinn Dagatness. Just one comment. Because 3 of them, they might come out at different times. So I think it's a better idea to have separate documents for all of them because, yeah, there are good chance that they will be finalized by NIST at different times. And you don't want one to tie down the unfinished to tie down the finished one.
Thanks very much for that. It's very helpful.
Richard.
Yeah, thanks. So thanks for putting this together, Mike. I think this is an obvious no-brainer to get these algorithm identifiers specified basically as soon as the algorithms are done. So I think my main concern here is not getting too far ahead of the actual algorithm standardization, but it's like as soon as those come out of NIST, like let's roll. As far as document number, I think Quinn's point is probably good. If not for that, I would say just put them all in one and not incur the process overhead 3 times. But if there's risk of, if we can go faster with some of them by decoupling them, by all means.
Ori.
So one of the authors, I agree with splitting them up for the reasons mentioned, and also for the reason that the Sphinx test vectors take up most of the spec size today.
And most of the container compute time in generating examples in test vectors.
John.
Hi, yeah, I'm just, we had a hackathon on the weekend for the X509 side of things, doing exactly this with the PQ keys and signatures. So I'm wondering, there's obviously overlap here, so we should probably talk and, make sure, because the object IDs, the same things that you were bringing up are the exact same things that we're dealing with. Plus, we're also doing the composite, so that would be something to also maybe consider for this.
Yeah, absolutely. And also appreciate all your inputs on the Entru stuff we're working on. And I'm very thankful that we're having conversations and have like a mailing list for this stuff because it's new and we need to cross-communicate on this. So thanks again for your support on this.
What working groups and or individuals are doing this work in the context of X509?
Yeah, it's mainly people from the LAMPS working group, because it's dealing with the PKI artifacts. That was where we started from, but obviously PQ goes beyond just the PKI artifacts, right? It goes everywhere. So, and so there was actually a side meeting yesterday too about talking about a PQ side working group and putting together a charter for all that. So yeah, I guess we'll see how that continues. So.
Yeah, and in a quick context for those who might not know, Michael Osborne and Christine Klosterman are co-authors on this, who authored kind of the root level stuff over at the LAMP side of things. So we're in very close communication with both of them on pretty much a weekly basis.
Okay, but yeah, in terms of our hackathon, like we're gonna continue to work. So we can invite. We're happy to if people want to test COSE artifacts or whatever with us. We're having monthly meetings. I sent that to the LAMPS mailing list. I could send it to this mailing list and invite people too if they want to participate, because we're trying to come up with a framework for automated testing and to make sure all these new things work together. So I'll do that then.
Awesome. Thank you.
Okay.
Thank you, Ori, and then we'll cut the queue.
Just to say that Mike and I and others have all had conversations around the key representations and the encryption side of this, and if the working group desires for us to, create 2 new documents in addition to splitting these ones out, I don't think it's a tremendous amount of work, and be happy to help support that initiative.
All right, any closing remarks? Otherwise, we will go to Hank.
No, just really appreciate all the time and especially the support as a comparatively new author compared to some of the people that actually know what they're doing in this room. So thank you all.
So it says Hank on the agenda, but I'm not Hank. He's there. He can explain why that happened. But anyway, so I'm Mike. Sorry. Hello. Oops. Yes. I'm Mike. I'm part of this Git working group that's been very newly formed. Some of you probably don't even know it. It's supply chain integrity, transparency, and trust working group. We have our first real session on Thursday, so we're happy to join. We wanted to discuss one specific topic in this group here, and that's around the transparency aspect of it. So if you know transparency logs, for certificate transparency, for example, they all have specific formats on how to represent, signed tree heads, inclusion proofs, and all of that. And this again now becomes a topic for more general supply chain transparency. And so as part of the Git working group, we defined an early definition of what we call a receipt. And that's basically a bundle of a signed tree head and an inclusion proof for counter signature leaves. So what does it mean? It means you have a COSE sign 1 message that's your supply chain in a way artifact, and then or statement, I should say, and then that becomes part of a transparency log, and so you bind those two together with a countersign structure, for example, that's defined in COSE. So I don't want to say too much about the details. So I think the main point that I want to say here is we defined this new thing that's called a receipt, and it doesn't neatly fit into any existing COSE structures. So it's a new thing. And I think maybe switching to the next slide actually makes more sense here. So we had an early attempt on trying to shoehorn receipts and all the transparency bits into a signature algorithm and essentially reusing COSE as it is. That was not well received in the community because it was essentially a bit of an abuse of what a signature algorithm means, and it was just too much. So a better approach is just treat it as a separate thing, and there's this whole transparency aspect to it, and we don't want to hide it. And there is an inclusion proof, and it makes sense to expose that to the top essentially. So, and I guess what we're asking the COSE group is, does this make sense in principle? And then I guess there's a question of the registries that COSE has. So where would that fit in exactly? Would there have to be maybe a new registry for things that are maybe parameterized in our case? So one example is that there's not just a single type of ledger or transparency log. They have slightly different, let's say Merkle tree algorithms. And so there has to be some way to express that. And yeah, so there must be some kind of algorithm or ledger type. And I think that goes a bit back to the remark earlier that was on cipher streets. Shouldn't be a single long thing, or should it be a bit split up? But anyway, these are kind of details, and I guess, yeah, I have just 1 minute, so that's so think about that. I don't think we want an answer now, but also join us at Skit, and maybe yeah, we have one
and
slide.
we've got 5 minutes that you can use some of that if you want.
It says 40 seconds.
Yes, we have 5 minutes of all other business with no claimants yet.
Okay, good, thank you.
So finish in a natural way.
Okay, so that was this one topic. I don't know if you already want to get some feedback, because this is a completely separate topic.
Hank.
So this is Hank, just quickly on the receipt. So that definitely is a core element in the base work we are doing in Skit. And we really need this in COSE. So we will do this as individual document here very transparently. We hope for a comment. We were talking to Russ a lot, so he warned us for the biggest caveat, so that's why we are where we are. And we will create a stable proposal, how this looks like. And then I hope if everybody is satisfied enough that we can actually ask for adoption. But this is not yet, but soonish actually, I think. So that's just my comment, that we want to proceed with this, not in a slow pace, but actually want to have a first stable thing that is adoptable very soon.
I guess
Right, let's go to the other topic.
Mm-hmm. Okay, so now clear everything you had on your mind. This is a very separate thing. Probably most of you know about timestamp tokens. They're an old thing. They're mostly used to, in things like signed software packages used in Microsoft Authenticode, but also for signing documents, PDFs. So it's just to make a good use case is to make the verification of a signed document be valid for longer than the original certificate was valid for. So the idea here is COSE doesn't have a header parameter that allows to embed timestamp tokens in the unprotected header. So this is simply a proposal to say, let's define the code point and including, how to actually, what to do with that, how to embed it. And then applications can use that to timestamp COSE messages. So it's very simple.
So clarification question, did you say unprotected header? Why?
Yes, because it is a counter signature by nature. And that's why it can't be in the, so first you have to do the signature and then the timestamp is against the signature bytes.
Okay, Russ is nodding out in the peanut gallery there. Thank you. Anyone want to join the queue or provide feedback? Hank.
So this is Hank again, and this is a comment, not actual feedback. So this is a migration path solution. We don't want to use TSTs forever, but we accept the fact that they are the most common and established thing to use today. And so if we want to move to something cooler, like say an epoch marker, that's fine, or a signed zero time tag, that's cool. But for now, this is, I think, a necessary solution when you want to use infrastructure that is in place. And that's why this could be perceived as a mid-term migration path solution. But if we don't standardize it, well, it's just random.
That's all.
All right. All right. Thank you. We are 1 minute from time. I appreciate all the engagement today, as does Evo, and we look forward to seeing you all on the list. Thank you for coming. Thank you for taking notes.
Late, so most of my comment was about the CERT.
The CERT representation draft?
About that there are two resource records which hold certificates. RFCs 439886 and 607998. And that, how do we update those two? Do we update those two in this draft, or do we make a separate draft with to get updates to those two RFCs?
What do those two RFCs do?
One of them is for Dane Dance, the TSA resource record. The other one is the certificate resource record, which has also different certificate types. Well, Dane Dance is around for that one, but the older one, nobody owns that one. $43.98, nobody owns it. I just sent it to the list. I actually sent the list back in July. I just went back in July. And it's a value to me. It's a big value to me.
Is Dane interested in doing Dane work?
Well, dance would be, yes. But then it makes sense if we do one draft updating both instead of having Dane do one and send this to the other. So we have these two resource records where certificates are held.
You know, you might explicitly ask her.
Okay. He left. That's all me. Yeah, okay, Paul.
Those are chairs. Certainly, we see it happen here, but there's places with more subject matter expertise. Thank you.
I was part of the original team that was looking at doing this in chat.